Hello, MCT4C. Welcome to our first lesson together. I am concerned that you won't be able to hear very well. I do hope you have good speakers. I'm also concerned because I'm not comfortable with this medium, so I'll do the best that I can and we'll talk about it tomorrow. This day 2 lesson is back to vectors and forces. We are going to start by discussing the fact that a force is a push or a pull with magnitude and direction. Okay, so a force pushing your toboggan, pulling a piano across a room would be a force measured in newtons. A velocity is a speed with direction. So when we talk about going 100 kilometers an hour, that is merely a speed. If you say you're going 100 kilometers an hour to Kitchener, that's a velocity. Any quantity which is described by both magnitude and direction is called a vector quantity. From page 44 that you did last night, you would know that there's a difference between a scalar quantity, which only has a magnitude, and a vector quantity, which would also have to have direction. We're going to be doing 5 examples together today. Example number 1. You have a northwest wind blowing at 30 kilometers per hour. Let's draw a diagram as best as we can. So I need to have a vector that has magnitude and direction. So I want it to have a tail and a head, and I want it to go there. So I'm going to label my vector. Its head is where we put the arrow, it's where it's going. The tail is where it started. The magnitude is how long you create your vector. And the direction is the angle where you place your vector. Generally speaking, if we're doing mathematical vectors, which would be similar to this one, we would have a vector with a little small case letter with a little arrowhead over top of it. That is vector little p. Or we can draw a vector with the tail marked with a capital letter and the head marked with a capital letter, and we would call that vector PQ with a little arrowhead over top. So its name is PQ, always in the order tail, head. If you put absolute value bars with vectors, that would mean the magnitude of vector PQ. Another word for magnitude is size. Our vector size was 30 kilometers per hour. This vector has been given to us as a diagram. Its magnitude or size is 650 newtons. Its direction is 90 degrees to the horizontal. We could also say that was north. Or it has a bearing, if you like to sail boats, of 0 degrees. Bearings always come from the north. Example number 3. We are looking at a vector compared to an XY grid. Let's mark our north, south, east, and west, in case we forget. West, east. This is a vector because it has both magnitude and direction. Its magnitude is 1,000 newtons. This vector represents a force. Its direction is 30 degrees. We would say that that direction is north, 60 degrees, east, which means head north, turn 60 degrees towards the east. You can write that direction as east, 30 degrees north, but we tend to start with the north or south and finish with east or west. You can also write that direction as a bearing. Bearing always starts from north. So if we're headed north and our vector is here, that would be a bearing of 60 degrees. Example number 4. This is supposed to be a vector. There we are. We have another force. It is 170 newtons at 40 degrees from the north. So we are going to write its magnitude is 170 newtons. That is a scalar quantity. To be a vector, we also need direction. I guess I've said that a few dozen times, haven't I? Direction can be written in a number of different ways. Its first direction can be written as head north, turn 40 degrees towards the west. You could write that direction as a bearing. With a bearing, we start north and always turn clockwise. So the bearing for this one would be from here all the way around to here, which would be 320 degrees. Don't forget there are 360 degrees in a circle. Equal vectors have to have both identical magnitude and direction, but they may have different positions. So, if you have a vector like this, an equal vector could be way over here, but have the same direction. Pretend with me here. Same direction and length. Let's take it low. Those would be considered equal vectors if they have the same magnitude and direction. But may have different positions. For example, equal vectors could be going from Dairy Queen to Walmart at 10 kilometers an hour, or going from the Ag Hall to the Catholic school at 10 kilometers an hour. They have the same direction and magnitude. Opposite vectors have equal magnitude but exactly opposite direction. Let's do vector u. So if I just have one letter designating a vector, it would be lowercase, and it's going to have a little arrowhead over it. So there is vector u, and vector v is the opposite. So slightly different position, but exactly the opposite direction and the same length. They are opposite vectors. Last example. We have a vector that is positioned here. It has a length of 100 kilometers per hour. And we need to give a bearing for this one. So this is the magnitude. The bearing, starting from north, turning clockwise, is right here. There are 90 degrees in this guy. There are 60 degrees because 60 and 30 is the next 90. So we know that the bearing is 150 degrees. If you wanted to write it as a direction, there are lots of options. You could say head south, turn 30 degrees towards the east. You could say start east, turn 60 degrees towards the south. You could be just silly and say start north, head 150 degrees towards the south. That one's silly. And I think I lied to you. I think there's one more example. Yes, there is. This is a rhombus with all four corners 90 degrees. Vector AB, so we can write a vector with capital letters where A would be the tail and B would be the head. There is vector AB. It is equal to vector DC. So if you look at a little vector here, it is an identical vector to vector DC. Despite my drawing, they are going in the same direction with the same length. This is a rhombus. We can say that the magnitude of AB, can write it like that. So the size is identical to the magnitude of DC. We can also say that vector AD, so let's make him green, vector AD is equal to the opposite of vector CB. So C to B starts at C, ends at B, so we draw our vector this way. There's his tail. So A running to D is the same magnitude, opposite direction. They are opposite vectors. We can write one with a negative sign in front of it. However, the magnitude of AD, even though it's in the opposite direction, would still be the same as vector CB. Do you remember from grade 9? The diagonals. Right here, AC. The magnitude of the vector AC is the same as the magnitude of the vector from B to D. But they cannot be equal or opposite vectors because their direction is not the same or exactly opposite. You need some practice. Yay! I have some things online for you to look at. Handouts. 5.7.1, 5.7.3, 5.7.4, and then in your textbook, page 45 and 46, number 1 to 14. I'll see you tomorrow.